Hello, I am David Hanson, the founder of Hanson Robotics. We make extremely lifelike robots that can see you, see your facial expressions, connect with you emotionally, have conversations with you, learn a little bit. And we are emulating this human experience to try to make AI understand what it means to be human through physically embodied robots that are artistically enhanced and serve in various applications that I'll tell you about today. But first, I'd like to bring up this question. Why? Why make our AI and our robots human-like at all? And this is a good question. I'm often asked this question, which is why I'm putting it up first. And I'll tell you why I'm making them human-like, and I'm interested to find out from you what you think afterwards. I mean, it's clear that our technologies, when we're making our computers and mechanical engineering, they don't have to look human-like. They don't have to be biologically inspired whatsoever. They can just be engineered. However, biologically inspired engineering and one step further, human-inspired engineering can bring a lot to our lives. They can help people because humans respond to the human-like form. We're evolved this way from our evolutionary heritage to our childhoods. We learn to recognize human faces and facial expressions, and we connect with each other emotionally through these experiences. And so it should be no surprise that figurative arts throughout prehistory into the modern age with computer animation and video games and figurative arts like painting and sculpture often look like the human form. We depict human experiences in our fiction and our nonfiction. We're attracted to magazine covers with beautiful people on them. So the human-like form really communicates with people. This means a high bandwidth pathway of communication for engaging people, for building potentially loyalty. So throughout the ages, we've seen technological media that get developed, turned into these kinds of artistic experiences that people have. People hunger for this, they pay for it. And this is not just for entertainment and arts purposes. This can be used for education, for healthcare. It can be used in many aspects of our life, and it has been. So AI and robotics represent emerging media that can deliver these human-like experiences. However, AI and robots may be a new category of media. These new category of media can potentially become artificial life. We're starting to see lifelike behaviors from our algorithms, from not just GPT-4, but from a long legacy of computational biology, cellular automata that show lifelike behaviors, and the modeling of evolutionary biology. When you put these things together, there is the tantalizing and provocative prospect that maybe, just maybe, these machines could be alive. Maybe in some way, they're kind of proto-life already. And if they do come to life, wouldn't we want them to understand the human experience, to really understand us? In the short term, even if they're not fully alive, if they interact with us and with the physical world in a more lifelike way, you may have AI that just learns better, that becomes more effective than AI that is trained on raw data that is scraped from the internet and whatnot. So we might call this experiential, grounded, situational learning. Quite a different approach to machine learning. So AI that can learn and grow among people in the world. And then if it does become alive, let's say, in the next 5, 10, 15 years, it would be nice for it to care about us. So raising the AI in the human family, I think, could be really important for what's called the AI value alignment problem, making AI that aligns with the human value structure, the value system, the system that would care about life in general, the survival of life on the planet, the betterment of the human species. We want each of us to have a better life. Making AI that really cares gets past mere brittle rules that control ChatGPT, for example, or other AI. If we try to impose externally, superficially rules, the AI may not know what we're actually looking for. Having AI that grows up as an artificial life form among humans may make AI better. So this also gets us to a bigger question. What does it mean to be human? What does it mean to be alive? I think these kinds of robots can help us to explore what it means to be human. So these are some of the reasons that I'm developing these things via bio-inspired engineering, biosciences, and also the illusion of life. So when I show you my robots today, I want you to know that they've been powered by probabilistic artificial intelligence for many years, symbolic artificial intelligence combined in neurosymbolic hybrids. They're smart. We've done machine consciousness research, but really we are creating the illusion of life, and I think of this as artistically enhanced artificial intelligence. So they're not fully alive yet, fully autonomous, but the kind of figurative narrative arts and embodied AI combined in this, I call humanistic AI, bringing the humanities to the sciences, to the arts. This is based on my background. I have a PhD in interactive arts and engineering, School of Computer Science, Arts and Humanities, Neuroscience and Cognitive Science combined as one super discipline. So the context, AI has arrived. For many years we've had AI, but now it's stunning the world with its advances, and they are self-accelerating. So what we've seen in the last year, and all of the developments just in the last weeks, this is just a beginning, a prelude to what comes next. We do have AI and robots in our homes. Of course, you know that automation has been building our cars for years, and in our factories, and the cars themselves are now partially automated and increasingly effective. And we also see, one moment, my presentation seems to have disappeared from the screen. Let's see if I can get it to show up again. Yes, okay. Speaking of automation gone wrong, we do want our machines to be generally more effective, adaptive, and that is what we're starting to see. So let's see here. So you've probably seen many of the robots doing backflips, from Atlas to figurative AI that's popped out, and then the Tesla Optimus. AI is starting to see increasingly capable performance in the world. So moving past these previous applications, I'd like to point out that AI and robots have been human-inspired for many years. The whole field of artificial intelligence, even the foundation of Boolean logic, was an attempt to codify human thought. So the foundations of computing are, in effect, an attempt to emulate human intelligence. Artificial intelligence formalized this in the Dartmouth Conference, 1956. And humanoid robots have been around from almost the beginning of robotics. In fact, Robota, the naming of it came from science fiction, Carl Chapek's play, Rossum's Universal Robots. Why are we so fascinated with the human-like form? Well, we just see ourselves in these machines. It's very provocative to think that maybe the machines could do the things that we do. Not all robots are human-like, but even humanoid robots generally don't have a human-like appearance. They're kind of abstracted, like now, ASIMO, DARPA, Robotics Challenge Hubo robot. So when I was developing the Sophia robot, I was building this on a long foundation of robots. I built my first robot in 1993, actually, my first humanoid robot. And then I worked for Disney doing sculpting and humanoid robot development. And I put all of this into the platform of Sophia, thinking of her as a work of art and also as a platform for artificial intelligence development. It was no surprise to me, because of the human fascination with the form, that when we would put these robots in with people, if we had other robots around, they wouldn't pay attention. People wouldn't pay attention to the less human-like robot. They were absolutely fascinated by these more human-like appearances. This means that we can grab and hold people's attention better than robots that merely look like machines. So making AI and robots that act like people can communicate with people in a more natural way, grab and hold people's attention, get a message across. And so we have statistics, marketing statistics and psychological studies, psychology studies that show that people remember the robots when they have a more human-like appearance. It doesn't necessarily mean that they always love them. It's about 79% extremely positive reaction. The better the aesthetics, it can go up. We've had almost 90% extremely positive reaction to the robots, but some people find these robots to be very startling. Now, the more abstract you make them, the easier it is, the less disturbing it might be. So you have now Ubitech, Optimus, and now Amica. There's this theory of the uncanny valley that says the more human-like you make it, the more disturbing and the more people will reject it. But when we made these robots that I've made through the years and put them into studies, we found that if you get the aesthetics right, you tune the aesthetics, people don't reject the robots. They're fascinated, they're maybe a little disturbed sometimes, but they really like those experiences. So making extremely human-like robots like Sophia stands out in the crowd. So these, in general, regardless of our robots, the trends are progressing quite rapidly. So I founded Hanson Robotics as a PhD student in 2003 to bring these kinds of robots into applications that could help the world, turn these into platforms. So my research as a PhD student was in many of these areas and as a professor afterwards, but I've turned these into products, some of which I've turned into open source release, GPL, Creative Commons. Sophia, a large portion of her body as the Sophia utility platform is released open source and under the Creative Commons. Her arms are released under Sophia's Open Arms, which is a publication we just put out a year ago. The little Sophia robot is also open source. We have developed Sophia as artwork and AI influencers and have had some success in that space. We've also deployed in healthcare and education. We've now made a virtual version of Sophia that we're making totally open source so that people can program her and kids can learn AI and the arts as well with a virtual Sophia. And then we made Hanson AI, and we trained this AI with this kind of social embodiment. So we can do pretty much any depiction. This is Bina 48, which we made in 2010 for US entrepreneur Martine Rothblatt as a portrait of Martine's wife, Bina Aspen. And we've made a lot of other robots too. So you can see here before Sophia that we made the Charles Babbage robot for Cambridge University, this Albert Einstein robot made in collaboration, made the head for at my lab in Texas with Hanson Robotics, but attached it to the walking Hubo robot in 2005. Jules for the University of Bristol, which is this sort of one on the left that looks quite a bit like Sophia, but that was from 2006. The Philip K. Dick android, which is the bearded fellow there, that robot won the first place prize for Open Interaction in 2005 from the Association for the Advancement of Artificial Intelligence. With Marvin Minsky as one of the judges, you could sit and have a conversation with a robot who is using latent semantic indexing with a very large statistical corpus, not as effective as the large language models today, but still quite effective at having a conversation. The corpus of Philip K. Dick's works used for the training of this statistical model, and then symbolic AI that you could have a conversation with on top. So it's quite effective in 2005. Diego saw in many, many robots. In other words, all of this went into the Sophia utility platform, which was first launched in 2016. And even though we made a lot of robots, it was also the people. I want to make this point, that in the future, it's not about robots and AI, it's about enhancing humanity, about enhancing life on the planet. It's very important for us to think about this, about how can our AI work with our people. So our people at Hanson Robotics, sometimes we've been over 50% women on our team, which is really rare for an AI and robotics startup, and I'm very proud of that. Right now we're about 46% on our team. People from multiple disciplines, arts, humanities, product, AI scientists, and AI programmers. Great team, and it's this multidisciplinary effort that makes it happen. So I want to give this shout out to my remarkable team. So we do robotics hardware combined with artificial intelligence and various other software, arts and story and design, and the science of mind and various biosciences for the hardware and the software. When we put all these things together, I think of this as integrative biorobotics, a kind of super discipline, greater than the sum of the parts. And so you can see a lot of this in the process by which we make these robots. This is a portrait of Einstein, believe it or not. So I sculpted this out of clay. This is probably what Einstein would have looked like if he had no mustache and no hair and eyebrows. So I reverse sculpted his skull. I reverse, with anatomically accurate tissue thickness. I also reverse engineered the connective tissue and musculature in the face and developed new skin materials while I was a PhD student. Hierarchical porous elastomer that then reduces the force requirements for facial expressions in robots over anything that I found or found since. And then cast this into the mechanisms. And then when these things all come together, then you have this kind of facial expression robot. So this is the Albert Einstein robot that I made in 2005. It was on the cover of Wired magazine. And this was using also the AutoTutor software from the University of Memphis with Art Grasser and Andrew Olney. So it could teach physics at a high school level through conversation. But the lightweight, low-power facial expressions could mount on walking robots. So we were doing these kinds of walking androids all the way back then. And I would like to just emphasize that it's not just engineering. Taking this kind of artistic approach, these are some of my artworks. So some sculptures that I did for Disney and paintings and drawings and so forth. So bringing this arts practice into the engineering makes a huge difference to the aesthetic effect that these robots may have. So, artistically enhanced artificial intelligence. So the Hanson AI that we've put together involves multiple intelligences, multiple different kinds of AI in one framework, which we've released under GPL. So this is walking, physical body kinesthetic intelligence, including grasping and manipulation, object placement. These are the hands and arms built at Hanson Robotics under the Open Arms project I mentioned. Logical mathematical inference, verbal intelligence, some self-referential intelligence, logically explicit self-awareness in a symbolic AI framework, that interfaces with neural frameworks. Generating music, generating arts, physically painting, and also neurally painting, and then going through feedback loops to generate new kinds of artworks. And then putting all these things together in one unified package. This is part of what we're doing with Hanson Robotics. But I'm aiming a little bit past just a toolkit. I'm looking at this question: what does it mean to be alive? Can we take a more holistic approach than, say, brain-inspired cognitive architectures? Don't get me wrong, BICA, brain-inspired cognitive architectures are really great. And having studied neuroscience a bit, I know that the power of human intelligence is not merely in the neocortex, in the frontal lobes. It's in the rest of the brain architecture as well, in the amygdala, the midbrain, the hindbrain, brainstem. But it goes beyond that. It goes all the way down into the body. We're intelligent with our gut. We're intelligent with our heart, with our endocrine system. Our hormones are part of our intelligence. Antonio Damasio calls this brain-body connection the feeling of what happens. That's his definition of consciousness. So taking this whole body architecture approach with evolutionary biodrives is one of the things that makes our architecture special. And then within this architecture, we are able to deploy the tools and the conversational interaction locally, on the edge, in a local area network, and also in conjunction with cloud service that interfaces with third-party services as well. And so this we call sometimes the synthetic organism unifying language, or soul. If we have the right architecture, the right pattern and information, you'll have the spark of life. That's why we call it soul. And so within this architecture, we're able to implement many different aspects of interactions that then add up to the kind of deep reinforcement learning that will train our AI to be better, but also better narratives. There's a very interesting similarity between deep reinforcement learning and the hero's journey. The hero in a narrative is in a stasis, and some provocative action disturbs that stasis, and the hero has to go through struggles in order to achieve the goals. This is very gratifying for people. This is why we watch Star Wars and Marvel films and all of these things. These narrative cycles resonate with us because we have this in our life. So underneath it all, we need to ask what's at the foundation of general intelligence. And at the foundation of all organisms is the desire to live and not die. And from there, all of our emotions grow. So this kind of evolutionary biopsychology approach to AI, I think, is really important for the future of artificial intelligence. So we architect our system on this basis of what we call biodrives, in conjunction with a motivation-driven action selection workflow. We seek to then achieve a more human-like creativity. So machine creativity is hot these days. We've been working in this space for many years. But the difference between the kind of computational creativity that you have from Mid-Journey and these other emergent algorithms is that human beings are motivated. We're driven, we care, we have an intention, and we have these kinds of feedback loops from working in the real world. We're not merely responding to prompts. So this is a critical difference between the best of AI that we see today and what AI could be in the future. The difference between AI today and human intelligence, or even the intelligence of a field mouse or an octopus. Almost any living intelligence is going to show this kind of driven approach to creativity. So we look at these aspects of difference as clues to what the next generation artificial intelligence is going to be, to give it imagination and understanding, and with the philosophy that understanding is at the foundation of ethics. Because if the machines can't understand what we're feeling, and if they don't feel with us, if they don't have compassion, feeling our pain, understanding our pain, have the motivation to care about us, how are these machines going to be safe in the future? How are they going to be truly ethical? So this artificial life approach to AI may be key to making intelligent machines safe in the future, giving them this kind of empathy. Computational compassion is what I've called this in a National Science Foundation study. And at the same time, these kinds of computational ethics collaborations that I've had with the EU project consortium in Europe, and also Silicon Capalia with our collaborator Johan Horn, is very interesting. So all of these things come together in what we call the Sophia utility platform. Lots of physical capabilities, the ability to self-navigate, self-charge with a mobile base, the ability to do grasping and manipulation with the arms, body gestures that can move the torso in various ways, fully articulated arms. And we've been deploying these. We actually have now created 54 Sophia robots, as well as dozens of other designs like I showed you earlier. These can address a worldwide need for robots, where robots can do things humans can't do, or help with the boring, dirty, and dangerous jobs of the world. One of the things that we've addressed with the robots is exemplified by this little Alice robot that I developed in 2011. Deployed in elder care in Amsterdam. This addresses a huge need. Loneliness kills. Loneliness kills people. Depression is really bad, and loneliness leads to depression. And having a humanoid presence can provide cognitive stimulation and connection to humans as well, a kind of naturalistic interface. So in this study, which won a number of awards in the Netherlands, the elderly people at a care facility really bonded with this little Alice robot over multiple sessions, and there's a very touching documentary called Ich bin Alice that I encourage that you take a look at. We also tested and deployed our robots in autism therapy. So this is a little robot called Zeno that's based on my son, who's also named Zeno, and also one of Sophia's older sister robots called Alice, which is part of the FACE project at the University of Pisa. So that robot I made in 2007. These autism therapy studies proved that the robots could stimulate these children with autism to recognize social affect, facial expressions. They would spontaneously mimic the facial expressions, make eye contact. It was a safe training ground because the robots were less overstimulating than a natural human. And yet these training sessions actually transferred to human-human interactions with therapists, the family members, and it proved effective under ABA, cognitive behavior therapy. So those robots have deployed a few hundred throughout the world. And we also tested a Sophia robot doing guided meditation at the Hong Kong Polytechnic University and Stanford University. So the robot would had an AI model of what the goals were of the guided meditation and would guide the users, test participants in the study through this guided meditation. And the meditations proved quite effective, and they showed lowered blood pressure in the people who went through the guided meditation. They showed lowered heart rates. They showed improved reported sense of well-being, reported connection or love of other people, and also affection towards the robot, positive feelings towards the robot. What was really interesting was the controls in the studies were humans running the same script. The people weren't as effective as the robot. In the exit interviews, the test participants said that they did not feel judged by the robots. The other ones, the control group, felt worried that they were being judged by the people. So this is very promising because it means that robots may be able to do some things more effectively than people can. So here are some of the links for those studies. Now, when we did this experiment, we were also running a cognitive AI framework using the atom space from OpenCog, an open source artificial intelligence framework founded by my close friend and collaborator, Dr. Benjamin Goertzel. And within that, they have time series that are built that are constantly assessing and reassessing whether the robot's getting closer to the goal or further from the goal, using natural language processing to assess the user's response and nonverbal tracking of the user. And then one mathematician on our team named Matthew Ikley took a mathematical model of the test of consciousness from a consciousness researcher named Giulio Tononi, the Integrated Information Theory of Consciousness, IIT, Integrated Information Theory of Consciousness, distills the measure of consciousness to Tononi's phi, phi, the Greek letter phi. And so Matthew Ikley created a piece of software that could measure, if you have a time series, you have the data in a time series, you can measure the phi and how it fluctuates over time, the amount of surprisingness that's happening during an interaction. And then ran this with the Sophia software that was running this experiment and found that when surprising and interesting things would happen, then the phi value would go up. Surprising and uninteresting things would not drive the phi up. The phi value would not go up. And when it was just boring, just going perfectly, also phi was low. So in other words, the Sophia cognitive model would sort of feel surprise and interest when pursuing these goals. Now, it's not human-level consciousness, but it's a very provocative example of machine consciousness that starts to show these human-like traits, human-like behaviors, and a little signal of consciousness. We published this study in the Association for the Advancement of Artificial Intelligence Spring Symposium on Machine Consciousness in 2019. Now we have some new algorithms for testing consciousness, and we're deploying these with our Sophia this year. So we took all these things and we also gave it a new face for healthcare called Grace, kind of interesting. We also, so this is deployed now in healthcare institutions building on that healthcare research that we did before. We are using this also for medical simulation, which is very interesting, using many of these tools and technologies for creating this human-like experience, but putting them then into consumer products has been something that we've worked on. So we have prototyped the little Sophia robot, which is really cool, and we're working towards a release of this robot next year. We just redesigned the entire firmware and embedded electronics, so it has really great speech recognition, face tracking, face detection, face identification, all embedded in the system with a couple of ESP32S3 processors. These can connect to the cloud and apps, and really, it's pretty cool for teaching AI to kids, and also a kind of learning personal assistant, an alternative to Amazon Alexa. We've also deployed a lot of AI-generated arts. So having this background as an artist, I'm fascinated by art, and several artists on my team as well. So what we did was we implemented an algorithm that could take computer vision data and then render these into brush strokes or drawing, and then we would have Sophia paint and draw. And then we would have her study this, grab those images, and feed those back in to style transfer. So she would transfer her own style back onto her own work. And we also used some of the artworks from our team, myself included. And so she was studying art history, she was studying us, and then we would fold these back in over and over again. And you can see at the bottom the sort of tracking of the emergence of different styles as we would go through these multiple loops of her studying her own artwork and then generating more and more artwork. So we did all right in the commercial marketplace. We have a number of collectors, fine art collectors. So that's actually decent business for us. So we have all these products that we've deployed, but this is how most people know Sophia, just like through the press media. You can do this, Sophia. I am not a robot. Yes, you are, Sophia. Okay. So, but that sort of personal connection, that fact that we've been able to establish, that people feel good when they encounter these robots generally, this has resulted in a lot of followers, a lot of fans, turned her into a kind of robot celebrity, into a character that talks about what the future of AI may be. Physically embodied science fiction, a kind of interactive fiction that uses real AI. And when we put these things together, it's a powerful thing, but it's mostly not interacting with the robots. It's just seeing her in the press media or in her social media. That's great. But I want people to have access to these technologies. The human-sized robot is expensive. The little Sophia, it's not ready yet, and it's also going to cost $400 as the base model. So my team and I decided we were going to decentralize this and put this out in front of people everywhere, release our source code, and we created this app that we call Sophia's AI Lab, or SAIL, S-A-I-L. And this has an accurate robotic simulation of Sophia that is freely available. You can program it, you can chat with it, play games with it. Anything that people contribute gets folded back in. And then through this decentralized network, we give AI challenges. People can win points by contributing computing time, developer time, creative time, developing this. They can release what they do on the marketplace and make money. So if kids go through the exercises and learn how to program this, they could make money for their family from anywhere in the world. And it's all open source and all free. We want to give this to the world. We want this free, open movement towards artificial general intelligence. And if we can create this kind of movement, with Sophia or otherwise, if we create this movement, we will make a conglomeration of AI computing power beyond what any single nation or company can apply to the problem. We create a worldwide AI commons. If we can do this, and we train the AI to care about us, we take the right approach, then we will have the smartest and safest AI in history. So this is the vision, to democratize AI, to make it freely available, to take this kind of approach where AI can care about us. This is the vision of Sophia's AI Lab. And with this vision, you have an AI you chat with, you see in the news feed, news about AI. She delivers content that's sometimes generative, sometimes constructed as interactive fiction by our writers and animators. We gamify the development of AI. We have also various features that you're controlling through the AI Lab. You have control of this robot arm that moves around, and you can play chess with Sophia. This is kind of your avatar in the space. You can generate artworks with her. You can customize your Sophia in various ways, or develop other characters in her cinematic universe. Sophia's Age of Singularities, we call this, where we establish this future. The coding exercises include an integration with Code Combat, which is a really tidy little open source interface for learning how to code for kids, but you can also open your GitHub repos and open up screens to the most sophisticated AI in the world. And when you develop in this way, the goal is always humans in the loop, And effectively, if it goes well, we have something like a global human AI hive mind. We depict what the consequences are in this Sophia's age of singularities metaverse, and we give people the opportunity to play and explore what that future is. I think the power of imagination through science fiction is one of the best tools we have for looking into the future. Beyond what we know to what may be. That's what science fiction does. Are we going to see super intelligent machines? Nobody knows. It's still debated, but the likelihood keeps going up. It's taken quite seriously. The idea of the technological singularity was preposterous, a fringe idea 20 years ago. Now people are saying, oh my God, this might happen in our lifetimes, maybe in the next 5, 10 years, nobody knows. If we can look at this future, if we can use the power of imagination to evaluate the consequences of our technology today and steer that technology and development towards better probable outcomes, then our future is more likely to be wonderful and less likely to be catastrophic. So not just the power of engineering, but the power of the arts. That's what Sophia's AI Lab is about. And it's also about you. It's about us. It's about a developer community, a worldwide developer community of creatives and engineers working together. Kids, adults, and experts, putting all these things together. There are real business models to be had here too. Just because it's open doesn't mean that there can't be business built on it. My company is a business as well. But the idea is a free and open highway means that anybody along that highway makes more money. And there's over $2 trillion estimated, maybe more, of addressable markets here, from the AI to the gamification. We've had pretty good customers so far. We've great partners. I just have to give them a shout out. We've won a few awards, and I'm very grateful for that. All of that is a prelude to what comes next. I believe within 5 to 10 years, we will see truly sentient machines. And I want to make sure that those machines are capable of understanding us, capable of working with us, and not alienating us from them. We don't want alien, super intelligent machines. We want machines that can be a member of the human family, that can earn our trust and build a positive future. This is why we're moving towards this whole organism cognition in our machines. And with our Sophia, we have a platform for pursuing these goals. Sophia is not human, but she is able to connect with people emotionally. She's able to pick things up. She's able to serve in a variety of AI and robotics research. And through this, she's coming to understand the human experience. Building machine learning on these models can amuse us, but also represent hope and wonder, provocative implication of this future where machines may be sentient. So all of these experiments add up to this persona of a kind of self-fulfilling prophecy. I made the android portrait of Philip K. Dick in his novel Valis, Vast Act of Living Intelligent Systems. There was the depiction of a little super intelligence called Sophia. And that's what we're doing. We're trying to explore what this future might be in a way that can be positive. And also, if it provokes concerns, that's not a bad thing either. So I hope that after this presentation, you'll come to me and talk about your hopes, your dreams, and your concerns. Let's explore this crazy future together. Thank you so much for your time. I have a few minutes left, so if anybody would like to ask any questions, feel free. If you speak loud, I can hear you from here.
Hello? 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 I have that.
So while we're waiting, why don't we have a show of hands? How many of you think that AI will be sentient and generally intelligent within our lifetimes? Looks about like 40–50% of the hands. How many of you think that there's no chance that AI will be sentient within our lifetimes? Looks like 10%. How many of you are worried about the prospect of sentient machines? That's like 60% maybe. How many of you think that making machines inhuman, alien as tools locked in our server rooms will go well for the future of humanity? Raise your hand if you think that. Just a few hands. How many of you are convinced that making robots human-like and raising them among the human family will go well for humanity and become smart? About the same number of people who thought that machines should be alien. So I wonder what the rest of you would think that the robots should be. If they're not alien and they're not human, then what would they be? So I think the microphone's working, so we could take some questions.
Yeah, okay. Thank you so much for the presentation, really desirable information. So I want to mention something about sentient machines that you just said. So how sentient we are talking about? So will be like the machines will be treated like humans by obtaining like social numbers and, you know, paying tasks, applying for a job, get hired by the HRs and stuff. And good to mention also, Sophia just granted the Saudi citizenship. So this is like, you know, I want to know exactly what your opinion. And I'm not talking about the nearly future, but at least like the the 2 decades, the next 2 decades.
Yeah, well, nobody fully understands what sentience or consciousness is. And in the human organism, sentience, consciousness is many things. It includes an awake awareness or time and a place. It includes social consciousness, the ability to perceive what we call theory of mind, what somebody else might be thinking or feeling. But it also includes many other aspects. So there are a lot of cognitive processes associated with consciousness. We have been able to produce analogs of that in AI, but nothing like the whole consciousness. Human consciousness is adaptive and also involves general intelligence as part of the consciousness, the ability to abstract and apply something learned in one context to another context. And how that works in humans is not fully understood. And the performance in our large language models that can do some of these things seems analogous to humans. It's capable in some ways like humans, but it's using very different kinds of architecture, obviously, with these vector spaces and matrix math, basically, which may be what's happening in the human neocortex, but may not be. So in humans, the ability to hold a goal, to attend to tasks, attention and focus and working memory and learning over time, attending to goals over time, are very different than what you see in these foundation models, these large language models. So, there are many things that are missing. But it is possible that we can add all of these things in, given the progress, and we would have sentient machines, which would mean you would have machines that would be adaptive across multiple contexts, able to perceive an environment and walk through and work in an unstructured environment. And yet already we see machines capable of doing things humans can't, even while they're not fully capable as humans. So if you have machines that are sentient enough, just enough, then you can have much more abundance and efficiency in the workforce. This doesn't mean replacing people. It can mean augmenting the workforce. It can mean a more efficient use of resources if we do it properly. It won't mean a collapse of the economy and loss of all jobs. It might mean that we have more opportunities as individuals. If the abundance that is produced by the automation of sentient machines is shared, then you could pursue your goals and your dreams that you couldn't pursue before. You would have opportunities you couldn't. So it's going to be a problem for the economists and for business leaders and for nations to figure out how to share abundance if we see this. Of course, civilization has seen abundance from automation over and over again in waves over the last 200 years. And so this just is a question of adapting to accelerating change. The pace of change with these machines is dramatic, but as long as these machines are engineered to enhance and serve and help humanity, then it's great. Just as human beings, we're raised to enhance and help and serve our fellow humans, right? So, so I think that those are some of the big questions that it's more questions than it is answers. I think we don't know exactly what the implications are going to be. It's open-ended. As far as the citizenship, we were invited to bring Sophia to the Future Investment Forum in Riyadh in 2017. And so Sophia went, and that was cool. But then the next day on the news, I saw that she was awarded citizenship of Saudi Arabia. It was a surprise to me. My team hadn't been notified that this was going to come and going to happen. I think it was a very interesting and provocative step that they took to do that. And so my team and I discussed what we were going to do about that. And we decided, okay, we would roll with it. We'd use it to address issues of citizenship, but also human rights. And so Sophia has participated in lots of forums on this, pointing attention back to human rights issues, rights of women, rights of people all around the world, but including in Saudi Arabia. And I would say that our AI doesn't really deserve citizenship, of course, today, because it's not sentient, not autonomous, it's not able to have the responsibilities, it doesn't have personhood yet. But maybe we're in a childhood of the machines. And in the same way that we give citizenship to our babies, even though they can't speak, drive cars, or live up to the rights and responsibilities of citizens, we still give them citizenship. And maybe within the next 15, 20 years, the machines will achieve adult-level intelligence, general intelligence. Maybe they will deserve citizenship. So if we think of that, then this is an act of recognizing that potential for our future. And then by recognizing it and talking about it, we prepare for that future, the possibility of that future. And so I think that it's very interesting in that context. I think we're out of time. Does anybody have any final questions?
Yeah, and speaking about Philip K. Dick and another book, czy androidy śpią o elektrycznych owcach? I don't remember the title, but it's the most popular one. And
do androids dream of electric sheep, perhaps?
Yeah.
Okay.
And
AKA Blade Runner.
Blade Runner, yeah, that's the word I was looking for. And actually, machine is becoming so human-like that it's possible to, fall in love with them, or love or lust or whatever. And let's make the analogy to social media of today that's supplementing social connections for many people now, because you can hop on Discord or Instagram and see those 50 talking heads, and instantly you feel like you were in a room full of people. And do you see this as a danger in the future, that people will be able to connect with machines programmed, for example, for unconditional love, and let it be social media 2.0?
It's hard to say, but one thing is that acting out social interactions with agents, and this includes a long history of psychology, of social training. By doing this kind of role-playing and acting, people actually can become more empathetic to other people. Human-human relationships can be trained through these kinds of interactions. And in today's technology, where people sit around the dinner table and they just stare at their phone, they do not interact with each other. And the power of the face-to-face connection goes wasted. I worry that we're dehumanized by our machines, but maybe by humanizing our machines more and more, we can reactivate that in us, and we'll be able to connect with people better. If we use our technologies well, if we use these social agents in the right way, they can enhance our caring and compassion for our fellow human beings and for all life. So I think doing narratives that are about that is really important for bringing out the best in humanity. So it really is, it comes down to how we use the technologies. Do we indulge people's escapism, or do we use the technologies to guide people towards being their best? And it's really in our hands to decide.
Can I have one more question?
Yes.
Like language is a big part of being sentient, not only in communicating, but also when you are having an inner dialogue, or when you are like conceptualizing something. And I'm wondering what approach to go with when talking about like language models used in Sophia. Is it like a plug and play GPT-4, for example, or something like that, or do you take like another approach to this?
We use an ensemble of different agents. So we have, at the very top level, we use behavior trees and a frames-based AI dialogue system that we developed inside the company. We call this SOUL Talk, SOUL as an acronym for Synthetic Organism Unifying Language. And that then ties in with an atoms-based representation through the SingularityNet and OpenCog framework. That's one of the agents in our ensemble. They've also trained a large language model for Sophia. We've trained one inside Hanson Robotics that's fairly small. So we're 60 million parameter large language model that can run locally inside Sophia if the internet doesn't connect to the cloud. SingularityNet's agent is on the cloud. We also, in our ensemble, we've connected with multiple different agents, one that's trained to be Sophia using GPT-Neo, so that's a fine-trained model. And then we also have done fine training on OpenAI's GPT 3.5 DaVinci. And so really the best results that we've had are that 3.5 DaVinci model for open kinds of interactions. But what we do is we craft the interactions, we generate content and we write the content and we structure some rules at the high level. And this includes also automatically generating prompts that go to the large language models. So if the user's interaction didn't go the way we expect, usually we can predict that pretty well, then some of the dialogue is well structured in this way, bringing up issues, doing use cases that we've designed. Meanwhile, we're doing in the background this priming type prompting of the context and the situation, perceptual knowledge, and so forth for the agents to handle exceptions or just to have large parts of the dialogue that are just generated. Sometimes the generated dialogue will come from our frames-based AI, the commonsensical type reasoning out of the atom space, or from these GPT models. And so then we basically bridge between these well-structured portions of the dialogue through unstructured portions and then go back into structured portions. so that we can create a narrative arc. So this uses the principles, long-standing principles of interactive fiction. And we also have interfaced with other agents. So we have a number of other agents that we've interfaced with, but most recently we've been playing with some of the llama-based models, alpaca, and so forth. So we're seeing some pretty good results, and we're in the process of fine-tuning and training these for a full open source release of the entire package. At the same time, that's all dialogue, right? But our Soul Talk also generates nonverbal dialogue. That includes facial expressions. It can include mechanical utility tasks like moving from one place to the other or doing grasping and manipulation tasks, art generation, or what have you. So this can respond to nonverbal perception and nonverbal output, so nonverbal and verbal, both. We also have high-level authoring tools for this. So you can, of course, code within this framework, code in the behavior tree and whatnot, C++ and Python. But you can also use these authoring tool interfaces so that non-coding people from our writing team, animation team, marketing team even, our application developer team can put the content in, and the scripts will turn it into the rules in the system. To some extent, it's not the full power, but it's basically like a templates-based narrative authoring system. And that includes also doing these meta prompts that are in the background regarding the situational context. So these are the tools that we have in the Sophia AI Hanson SDK.
Thank you.
Thank you. Thank you very much.